This is the last day of notes for the class. I'm so very impressed that you guys have made it through pre-calc, especially these last 7 weeks, and trying to do this remotely from home. I'm so very proud of you. Our very last day of notes is definite integrals, and it's the area between a curve, the x-axis, and x values of a and b. So I'm going to just kind of like lay out an example of what's going on here, and I'm going to walk you through these 3 examples. This is a very easy ending to the course. So say you have a function that looks like this. Say that's your function, and you want to find the area between the x-axis, this function, and maybe this x value of a right here and this x value of b right there. So say you want to find this area. Well, this shape, this shape, even though these are straight lines, this is some kind of a weird curve. We do not have any area formula to find a shape like that. So what you would do, and this is kind of what I was alluding to yesterday at the very end of the notes, is you would take this area and you would break it into rectangles that are below the curve, and you would find the area of each of those rectangles. So say you would have, this rectangle right here that's below the curve, this rectangle right here that's below the curve, this rectangle here, and this rectangle here. So say you found the area of those 4 rectangles. Clearly it's not the full area of the curve, it's a little bit too small. And then you did the same thing, but you made rectangles just outside the curve that would be a little bit too big. So you would make a rectangle this big, which is too big, outside of the curve, which is too big, up here, which is too big, and up here, which is too big. So then you would find the area of those rectangles, and you would take all the areas of the rectangles under the curve that are too small, add those together, and you would take all the areas of the rectangles that are outside of the curve that are a little bit too big, you would find those areas and add those together, and when you average those 2 numbers, that would give you the area under the curve. And I said this yesterday, it's called Riemann sum, and I remember way back when I took Calc 1, that was one of the first things that we did, and I know Mr. Donovan will be starting with that next year in AP Calculus, and your Calc 1 teachers will be teaching you that if you're taking it in college. But the way to do it without finding those rectangles and averaging them is something called a definite integral. So what you do is you integrate the function, you take the number that's on the top of the integration symbol, you plug it into the integration, you take the number that's on the bottom of the integration symbol, you plug that into the function that's been integrated, you find those, you subtract them, and that would give you your area. So for example number 1, this is going to be called a definite integral because we are going to integrate the function 12x squared minus 5, which is a parabola. It's an x squared parabola. We need our dx outside here. And I'm going to find the definite integral, or the area of this function, the x-axis, between x values of 2 and x values of 7. Okay? So first thing I have to do is I have to do the integration, and when I do the integration, I'm going to drop off the integration symbol and drop off the dx. So when I integrate this function, I'm going to move the 2 and the 7 to here because I need to keep those to plug those in when I'm done. So to integrate this, it's going to be 12x, bring your exponent up by 1, cubed divided by 3, minus, this is 5x to the 0, so 5x to the first divided by 1, plus c. So that's what we did yesterday. What's inside those brackets is the integration. Now what you're going to do is you're going to plug the top number into this, then you're going to plug the bottom number into this, you're going to subtract those, and that will give you the area between this parabola, the x-axis, and x values of 2 and 7. So first, I'm going to just clean this up. This will be 4x cubed minus 5x plus c, and I'm integrating this between x values of 2 and 7. So the first thing I have to do is plug the 7 in. So it'll be 4 times 7 cubed minus 5 times 7 plus c. Then we're going to subtract, filling the 2 into this integral. So 4 times 2 cubed minus 5 times 2 plus c. 4 times 7 cubed is 4 times 343 minus 35. This is 1,337 plus c. 4 times 2 cubed minus 10 is 38, or 32 minus 10. This is going to be 22 plus c. Distribute, so 1,337 plus c minus 22 minus c. Those c's cancel, and you're left with 1,315. So that would be the area between this function, the x-axis, and x values of 2 and 7. If this turns out to be a negative number, it's a portion of the graph that's below the x-axis. So if it's easier for you to always put the plus c in like you need on an indefinite integral, you certainly can. But when you're doing a definite integral and you subtract, those c's will always cancel. So for an indefinite integral, you don't need to keep the plus c in when you do your integration. Let's run through the last two examples. All right, so example number 2. We want to integrate between x values of 1 and 3, and the function is 6x squared minus 4x plus 3 dx. First thing we're going to do is we're going to integrate. Remember, when you integrate, you drop out the integration symbol in the dx. So when I do the integration of that function, it'll be 6x to the third divided by 3. So you bring your exponent up by 1, divide by the new exponent, minus 4x. This is an x to the first, so this will be x squared divided by 2. This is 3 times x to the 0, so it'll be 3x raised to the first divided by 1. If we were doing an indefinite integral, you would need plus c here because there would be a constant, but because we're integrating and we're going to subtract these two, those c's would drop out. So for a definite integral, you don't need to include the plus c. And we're integrating this between x values of 1 and 3. Simplify the integration. So when I simplify this, I'll get 2x cubed minus 2x squared plus 3x. I'm integrating between x values of 1 and 3. Plug in the top number first. So 2 times 3 cubed minus 2 times 3 squared plus 3 times 3. Whoops, I was using under parentheses. Then plug in the bottom number. You're going to subtract 2 times 1 cubed minus 2 times 1 squared plus 3 times 1. Now, if you had a plus c here and a plus c here, those would cancel. This whole parentheses works out to be 45. That whole parentheses is minus 3. So the answer is 42. Okay, one final example of new material for the entire course. Again, I am so very proud of you guys and the effort. Someday you're going to look back at this and maybe tell your children or your grandchildren, you say, I remember when I was in high school and I was learning that math class. Can't remember what it was called, but in the end, we couldn't go to school and we had to try to learn it by ourselves online. So, guys, you've done a wonderful job. You've done an absolutely phenomenal job. I'm so very, very proud of you. I wish that we could have been together in school for the end of this, but let's get through this very, very last example of new material for the course. Here we go. Example number 3. We are integrating the function 8x plus 4. Okay, so we have our integration dx, and we're integrating that between x values of 0 and 5. First thing we're going to do is do the integration, drop off the integration symbol, drop off dx. So when I integrate, it'll become 8x. The exponent here was 1. Bring it up, so it'll become an exponent of 2 divided by 2. This is 4x raised to the 0, so bring it up by 1. 4x raised to the first divided by 1. We don't need the plus c for our definite integral, because if you put a plus c in here, when you plug in the top number and the bottom number and you subtract, the c's will cancel. And we're integrating this between x values of 0 and 5. Clean up the integration. So the function will be 4x squared plus 4x. We're integrating it between x values of 0 and 5. Plug the top number in first. So 4 times 5 squared plus 4 times 5. Subtract off, plugging in the bottom number. 4 times 0 squared plus 4 times 0. This whole thing turns out to be 0. 5 squared is 25, times 4 is 100, plus 20. So the answer would be 120. Congratulations, you did it, you did it, you finished pre-calculus. I'm so proud of you, I'm happy for you. I hope that whatever day you're watching this video, the weather is nice. It's sunny right now for me, but I'm doing this, I'm videotaping this on Thursday, well, I don't even know what the date is, May 7th, I think. But well done, guys. Don't forget tomorrow that you can join. So tomorrow will be Wednesday, May 13th, and your test is on Thursday, May 14th. Tomorrow, there will be 2 Zoom classes set up that you can log into either one or both of them, and you can ask me any questions at all on derivatives and integration before you take your test on that. On Thursday, there will be your first end-of-the-year review sheet that'll be due on Friday. After that, you'll have 3 more review tests, and it's going to finish up the 4th marking period and finish up this course. Guys, I hope you're having a great day. I miss you all.